Hi, welcome to Lesson 11, Session 4. Today is our refined session, and we will be taking everything we have learned about subtracting decimals, and we will use many different strategies to solve these subtraction problems. So we're going to take everything we've learned over the last 4 or 3 days and put it all together to show what we know. So we're going to be working in our math workbook on pages 221 through 224. So go ahead and take out your Ready Classroom math workbook and turn your book to page 221. Okay, so we've got 8 problems that we're going to do today. The first problem is this. It says, on average, outdoor cats live 3 and 1800 years, and indoor cats live 16 and 7/10 years. Holy cow! Man, indoor cats live so much longer than outdoor cats. That would be a really good conversation to have, why you think that indoor cats live so much longer than outdoor cats. But that's for another day. How much longer does an average indoor cat live than an average outdoor cat? Show your work. So what you need to do is so we know this question is about cats. The question we're trying to find out is how much longer indoor cats live than outdoor cats. And then our important information is that indoor cats live for 16 and 7/10 years on average, and outdoor cats live for 3 and 1800 years on average. So to solve this, you need to take your longer value and subtract your shorter value. Or if you'd like, you could also use an adding on strategy where you start with the shorter value and you add on until you get to the 16 and 7/10 year, and then add together all of your what you add on. Whichever strategy you prefer is the way to go. Go ahead and solve that, and then go to number 2. All right, number 2 is a 2-step problem. So the problem says, Ling pays $2.12 for a gallon of milk and $7.79 for a 64-ounce jar of peanut butter. She uses a coupon to get $1.25 off the price of the peanut butter. How much does Ling pay for the milk and peanut butter? Show your steps. So remember that a coupon makes things cheaper because it saves you money. It's taking money off the total price. So what we're going to do first is we're going to find out how much did it cost Ling to buy the milk and to buy the peanut butter. And we're going to add those two values together. That's going to tell us how much money she spent before she gave the grocery clerk her coupon. And then you're going to find that answer and then move that answer over here. Then you're going to give the fake coupon to the grocery clerk, and it's going to take $1.25 off your total, off your total from the first part of the problem. And then here you will get your final answer. Number 3 says this. 3 boxes of cereal have masses of 379 and 4/10 grams, 424 and 2500 grams, and 379 and 3700 grams. What is the difference between the masses of the box of cereal with the greatest mass and the box of cereal with the least mass? So there's 2 things you have to do. The first thing you need to do is you need to put the cereal in order from least to greatest. So looking at these 3 values, you're going to figure out which one is the least and which one is the greatest. Then, making sure you do that, you're going to go ahead and put the least number here, the middle number here, and the greatest number here, or the smallest, the middle, and the biggest. Then you're going to take your greatest number, your biggest number, and you're going to write it on this line here. Then you're going to take your least number and you're going to put it on this line here. And then making sure you line up all of your place values. That's the most important part. Don't forget to line up place values. Once you line up your place values, then you're going to subtract and get the total number. Now, Cambria chose D as the correct answer. So if she's right, you're just going to tell me how she got that answer. If she's wrong, then you're going to tell me what Cambria may have done that got her to the incorrect answer. Number 4. Number 4 says, what is the value of the expression 13 and 25 hundredths minus 11 and 4 tenths? Go ahead and use your best strategy to solve this subtraction equation. For number 5, it says, which equations can be used to represent the bar model? So here we have the total, which is 14 and 74 hundredths. We have a part, which is 5 and 30 hundredths. And then we have another part that is the value of n. We do not know what that other part is. We could solve for it, but that's not what the question is asking us to do. On this particular question, there are 2 correct answers. So 2 of these would work. So go ahead and figure out how you might find letter N. If you don't remember, you can always go back into lesson 3 and look for an example. We did a couple of different examples of this similar type of problem. So if you don't remember, go back to lesson 3 and look for what we came up with in lesson 3. Number 6 says 2 boxes of books have a total mass of 35 and 1/10 kilograms. If one of the boxes of books has a mass of 22 and 800 kilograms, what is the mass of the other box? So you're going to go ahead and subtract 22 and 800 from 35 and 1/10. Or you're going to add on from 22 and 800 to get up to 35 and 1/10. Use your best strategy to solve this problem. Go to number 7. Number 7 says, choose all the models or expressions that represent the difference of 3 and 7/10 minus 1 and 200ths. Remember, you might have an adding on strategy or a subtraction strategy. So you have to think about what this is asking. On number 7, I will tell you that there are 3 correct answers. So there are 5 options, 3 of them are right. So which 3 show us 3 and 7/10 minus 1 and 200? And then finally, number 8 says, show how you would find 2 and 62 hundredths minus 1 and 91 hundredths. Explain the strategy you chose. Here, you don't need to explain in words. You can go ahead and just explain by showing your work. And choose the strategy that is your best strategy. If you need any help, you can always go back into earlier sessions and look at your notes. And as always, you can email your teacher if you have any questions. Otherwise, I'll see you next time.